In this question, you're asked to prove that 0 to pi x tan x by secant x plus tan x is equal to pi times pi by 2 minus 1. So let us try using some properties of integration. So let I is equal to integration 0 to pi x tan x by secant x plus tan x dx. So using the properties of integral, I can put pi minus x in the place of x. So I is also equal to 0 to pi minus x into tan pi minus x is minus tan x divided by secant pi minus x is minus secant x, tan pi minus x is minus tan x dx. So this minus, minus and this minus, all of these get cancelled. So that is equal to integration 0 to pi tan x by secant x plus tan x minus x tan x by secant x plus tan x dx. So I is equal to this. Now let us add these two expressions. So this is the first equation, this is the second equation. So if you add these two, you can see that x tan x by secant x plus tan x minus x tan x by secant x plus tan x, they get cancelled. So 2i is equal to pi times integration 0 to pi tan x by secant x plus tan x dx. So this looks easier than the first expression because you have an algebraic expression and a trigonometric expression. Here everything is made of trigonometric expression. So that is equal to pi times integration from 0 to pi. So if I multiply numerator and denominator by secant x minus tan x, so I get tan x into secant x minus tan x by secant square x minus tan square x, which is equal to 1 dx. So this implies that 2i is equal to pi times integration of 0 to pi secant x into tan x minus tan square x. So minus tan square x is 1 minus secant square x. So plus 1 minus secant square x dx. So this implies that 2i is equal to pi times, what is integration of secant x tan x? Secant x. What is the integration of 1? X. What is the integration of secant square x? Tan x. From 0 to pi. That is equal to pi times secant pi is minus 1. Minus of secant 0 is 1. So minus 1 is minus 2 plus x. When you put upper limit, it becomes pi minus 0 is pi minus tan pi is 0, tan 0 is also 0, so you get 0. That is equal to pi times pi minus 2. This implies I is equal to, if you bring this 2 into the denominator, you get pi by 2 times pi minus 2. Pi by 2 times pi minus 2. If you send this 2 into the bracket, you get pi times pi by 2 minus 1. Hence proved. That's what you're asked to prove. Pi times pi by 2 minus 1.